Okay, thanks. Welcome. It's been a wonderful event. You know, I'm a co-organizer of this. I think it was like 95.5, I think was the percentage. So Chen has just done an awesome job on this. Wonderful to be here. We're going to talk, I'm a criminologist. I'm trained as a sociologist. So again, this is an example of applied research. Came to Chen and said, we were talking about interested in crime. And I study when and where crime happens is what I'm interested in. So I'm not interested so much in who commits crime, but when and where it might happen. And so that's what we wanted to do here is research has tried to measure the ambient population in a location. That's obviously notoriously difficult to do. One thought was, could we use Twitter data as one way to try to measure that? And that's what we were doing here. This work with a student of mine, Christopher Bates, Moshe Lichtman, and Porrick Smith helped along with this in this study. And so let me give you a setup of what we're interested in. Again, when and where crime happens, there's this routine activities theory in criminology, which it's almost a tautology. It says that crime occurs with the spatial and temporal confluence of these three things. So these three ingredients to crime: motivated offender, a suitable target, and the absence of a capable guardian. And so, like I say, it's almost a tautology in the sense that if you have an offender but you don't have a target, you won't have a crime. And if you have a target but no offender, you won't have a crime, etc. So in that way, it's just sort of a framework to think about crime. But nonetheless, criminologists have been interested in this and wanting to test it. Of course, the challenge is, first of all, we've gotten better and better data with spatial precision. So that part has gotten better and better. And it's only more recently that we've been getting better and better temporal data, at least on when and where crime happens. So that part was useful to us. But then the challenge was to try to know what's going on in a location, who's there, who's not there. And that's where the Twitter data became of use to us. That's what was important for us. So again, if crime requires this confluence, first of all, how do we measure this? How do we know how many people are in a place? And an additional challenge that I'm going to allude to here, but in the Twitter data doesn't solve for us, is how do we know if there's a bunch of people? We have a bunch of people here. How do I know which of you are offenders, which of you are targets, and which of you are potential guardians? Hard to know, right? And so we're going to punt on that today. But that's one of the almost the Achilles heel, you might argue, of this theory. But that's down the road to think about that. But so we certainly need to measure both the spatial and temporal components of this. So a key feature that I want to focus on here today, or emphasize in our study, is this notion of routine. So it's about routine activities. So our interest in using the Twitter data wasn't to try to know when and where people are in a place and do you see crime happen. That's could be of interest, but that wasn't our particular interest. Our focus is on this idea that there's routine patterns where people go. People go to certain types of places at certain times of day, certain days of the week. And that's an important part of the routine activities theory. And that's why we were interested in using the Twitter data, I'll show you in a little bit, for getting general patterns of when and where people are at locations. That's what the theory is based on, the idea that we all have our normal routines. Maybe we have one routine during the week and a different routine during the weekends. But the routines, nonetheless, there's some small deviations. But based on that, can we get a general sense of patterns of when and where people are in particular locations? Again, by time of day, day of week. So again, we're not interested in a particular day. And that's going to also be a benefit for us because we're going to use, similar to other studies here, we're using data based on geolocated tweets. And that's it's odd to say it's huge, big data, but it's sort of a sparse sample in a way, right? And so if we were trying to measure a particular place at a particular day or time, it's got a lot of measurement error. But if we're combining many, many days with the data, getting a little stronger signal, if you will. And so crime pattern theory is related to routine activities theory. It's kind of the geographic analog to it, focused on general patterns of where people go during different times of day and weekday and weekend. And so that's what we're focusing on here. So here's this challenge that criminologists have had. Okay, if we're theorized that it's important to know where people are, this ambient population, as they refer to it, how do we measure that? And there's different strategies that are out there. One Residential population, that's pretty easy to do, right? There's census data, we can collect that, we can measure that at pretty small geographic units of analysis. That part's fine, but again, that doesn't work because people wake up and then they go elsewhere. People come to different places, so that only gets us so far. One strategy, and I've done this and others as well, is maybe we try to use the presence of certain types of features as a way of measuring what's going on. I know where South Coast Plaza is down the way. It's a big mall, lots of shops. As a general rule, I can have a sense that during the daytime there's going to be a certain number of people that are going to go there, maybe in the evening, and night there won't be people. So we can use those as sort of proxies for what's going on. We might extend it even more by using information from the web, from Google, et cetera, to get hours of operation and that sort of thing as another way to sort of proxy for when and where, when people are at locations. One criminologist there's land scan data where they tried to combine business population or business locations and residential population, although that was in just trying to get the average population at a location over the day, over the 24 hours of the day. Our particular interest was knowing how many people were at a place at a particular hour during a particular time. So we wanted a little different information, and so that's why we were interested in this latter strategy of trying to use social media data. And people are starting to do this. It's a growing usage of this in the criminology literature. Here we're going to use these geolocated tweets. And for us, that's going to give us the number of tweets emitted by individuals during various hours of the day and various days of the week at very specific locations. And so what we're going to use is just that very precise information for us. That's what we want to do. So how do we measure temporality? So again, we have information on the date, time, and location of crime events. And so this is, like I say, it's a relatively new direction in criminology research. Before, it used to be you just count, you'd look at a location, you'd kind of put a window on it for an entire year, and you count how many crime events happen. And that would be your outcome, if you will. Say how many crime events happened the last year at this location. More and more now, if we want to think of it temporally, how do we look at certain times of the day or certain times at night, and then chunk the data, if you will. So some recent studies have done that use time use survey to say, okay, we're going to chunk all the crime events that happen during the workday hours, and then the crime events that happen in the evening, and then crime events that happen overnight, or something like that. Is that proper? Of course, that's just you're chunking up to those hours. So what we wanted to do is exploit this temporal precision that we have. So we don't want to just aggregate it to anything that happened during the daytime, because again, it's important. The routine activities theory is this spatial and temporal confluence of people. So we wanted to know what we end up doing is we chunk it into 2-hour time periods. We can go even smaller, but we found is that the crime data fortunately gets so sparse at that point that it doesn't really benefit us that much. So we can end up using that. Some have used these time use survey data as a way of trying to proxy for certain times of day that are more or less busy. But again, we have this advantage that we can just take this more precise information into account. There's a lot of there's not a lot of studies that are out there looking at tweets and crime. And when we search through the literature, the ones that do it, typically they're not taking advantage of knowing exactly when and where crime events happen. And our argument was that's very important. So studies that have done it, there's another issue. Some have looked at it. There was this one that used tweets by daily news sources, and then the relationship between burglary events at specific times, which was interesting, but there's this endogeneity because they're using daily news tweets are often in response to a crime incident rather than predictive of it, even though it was kind of being used that way. Another took the sentiment of people nearby where a crime event happened. But again, you have these same endogeneity concerns. So that's why we were not wanting to look at tweets at the exact time of a crime event. But again, we're just thinking of it as this general pattern going on. Some have used it as this better denominator. That's been a challenge for criminologists. What's the, if we compute a crime rate, what is the denominator used? Is it the number of people who live at a place, or is it the number of people that come during the daytime? And so they've tried to use tweets as computing a better denominator, but again, not what we want to look at, because again, we want to take into account this temporal nature of the data. Then a couple others here use the content of a tweet. Direction we want to go today, we're not going to be talking about the contents at all, but again, this study that did that didn't look at the time of day of events, and another one the same way. So what we want to do here is take this into account. So we use this crime data that our lab has collected. The Southern California Crime Study is referred to it. Tried to collect crime data for the entire Southern California region, which has been a Herculean task, dealing with police agencies. But we've got about 140 cities in Southern California. We're using data from 2012. Our Twitter data is from 2015. That's not ideal. But again, we're focusing on this routine pattern idea is what we're interested in. The crime data, we know the exact location. We aggregate it, if you will, to census blocks. But if you know what blocks are, they're very small. They're bounded by streets. So it's just an area. It's this very small area. So we use that. We use crime data from May to December of 2012 in that it matches the months of the Twitter data that we're going to use. We only had Twitter data from May to December. It's funny, a reviewer pushed us to do this, it's because seasonal effects, but it's like Southern California, what seasons are there here? But you know what? The results are actually somewhat stronger when we did this as opposed to the whole year. So I stand corrected. There's seasonal effects. Let that be a lesson, y'all. It's cold today. It's winter. So we classified 5 major crime types is what we did. So we're focused on more serious crimes: aggravated assault, robbery, burglary, motor vehicle theft, and larceny. Homicides, fortunately, are too rare, so we just didn't focus on them here. Again, like I mentioned before, we classify crime events into these 2-hour chunks based on the time of the day and the day of the week. And we classify into weekends and weekdays because we think there's different patterns. You could dive down and try to model by specific days, Monday, Tuesday. But when we look at it, Monday doesn't differ much from Tuesday, et cetera. We said the weekend starts at 6 p.m. on Friday and it ends at midnight on Sunday. We think of Friday night, and the evidence sure looks that way, operates differently than a Thursday night or a Wednesday night. So we start the weekend then. The Twitter data, for most folks here, this is pretty well known. So we're using the Twitter streaming API over this 8-month period, again from May to December of 2015. So again, it's grabbing these tweets in real time. And again, an advantage of it because we're bounding our query to tweets with geolocation coordinates. So for that reason, we don't think we're going over this maximum limit of 1% of tweets. There was a nice study that showed that that's probably the case, kind of comparing data collected in this kind of manner. And again, by collecting this georeference data over several months, our hope is that we're obtaining a more accurate picture of the spatial temporal patterns of people. So again, it's that idea in any given day, because of these various limitations, you're only getting geolocated tweets, et cetera, that you'd have a lot of uncertainty just if you had a few days. But we're getting many months. We're hoping that's giving us a better picture of the pattern of where and when people are going to locations. So again, like the crime data, we have the date, time, and location of the person for each tweet that we have. Again, we place these in the census blocks using the latitude, longitude, so it now matches up with our crime data. What we did is we had the user ID, so duplicate tweets by user ID that occurred during the 2-hour period in the same block, we eliminate, right? So we're not trying to, if you sat there in a place and tweeted 7 times, we're only going to count 1 of those tweets. So we're basically getting unique individuals in a block during a 2-hour time period. If in the next 2-hour time period you tweet again, we're going to count you then again at that point. So we get you there. So that's what we're capturing. And then we're going to sum up the number of unique individuals at a particular block during a particular 2-hour window over this 8-month period. And we had some extreme values, so we log transformed that after adding 1. That has some implications I'll talk about a little bit later when we're trying to say, are we getting targets, guardians, or offenders? We take into account standard measures that criminologists look at. We measure characteristics of the block and characteristics of a half-mile buffer around it. A lot of studies have looked at that, so we take these various things into account. We wanted to see, are we getting an effect above and beyond that? We also wanted to know, do tweets provide additional information beyond one proxy that's out there in the literature, which is the presence of businesses. So we measured the total businesses at a location, then the number of retail businesses, because again, the idea that they pull in patrons to them as well. So we got that data from Reference USA from 2010. So we have additional models where we account for that and say, do the tweets provide additional information? Analytical methods for this, again, the outcome variable is whether or not a crime event occurred for that particular type of crime in that census block during the 2-hour period during May to December of 2012. Again, almost no periods had more than one crime event, so we're modeling the probability of occurrence of at least one crime event using logistic regression models. We correct the standard errors, and we tested quadratic and qubit models for log tweets. There's this challenge with this routine activities of offenders, targets, and guardians, right? If you've got a place, you have more offenders and you have more targets, then with more people, you have more offenders, more targets, so you think more crime. But you also have more guardians, so you'd think less crime. So it's this implicit nonlinearity in the theory, so we wanted to test for that. Turns out the linear version, although it's a linear of a log transformation, so keep that in mind. But that turns out that captured things better in the models. So the results first, this is what we found as far as the number of tweet activity going on over the hours of the day during our study period, split between the weekdays and weekends. So you can see people are generally sleeping in the early morning, and then it comes up and it peaks later in the day, and then it starts going down. But even between midnight and 2 p.m., there's still a fair amount of tweeting going on. More tweeting going on the weekend than weekday, as you might expect late at night. That's the general pattern. So what do we find for crime effects? So in each of these that I'm going to show you, so you see we're modeling a 2-hour chunk. So this is midnight to 2 a.m. This is our coefficient that we're getting, unstandardized coefficient, and the confidence interval around it. So you can see that almost all of these above 0, so we are seeing a significant positive effect in the sense that the more tweeting behavior going on, more, in this case, aggravated assaults occurring on weekdays. 4 to 6 a.m., it's just way too little information. It's effectively 0. But for all the others, much bigger effects. To give you a sense of it, for a 10% increase in tweets in a location, the log odds increase about 9.5% between midnight and 2 a.m. and about 9.7% between 2 and 4 a.m. So those are those. That's the highest, the biggest effect we get is that late night effect between midnight and 4 a.m. More people in a location, higher aggravated assault. In general, of course, far fewer tweeters, so that's an interesting effect as far as guardians, etc. But still, we get, throughout the rest of the day, still a pretty constant effect. That's weekdays. If we switch to weekends, we get an equally big effect from midnight to 4 a.m. So a big effect for the presence of people in those locations, a positive effect. Not such an effect during the later or into the early morning. And then during the rest of the day, we do again see this positive relationship between the number of tweets and aggravated assaults. Switching to robberies, it's a little more consistent pattern, a little bit of blip up there, but for the most part, similar during the daytime for weekdays. And then for weekends, again, pretty much a similar effect that we see between them. Switching to the property crimes, you saw for the aggravated assault, particularly in the robbery, we saw a bigger effect late at night. You don't see that so much for burglary. Of course, burglary is trickier because the timing of burglary events is harder to measure than like an aggravated assault or a robbery, so that caveat aside. But on burglaries, we're still seeing this generally consistent positive effect. If anything, though, it's bigger in the afternoon. And that's the weekend effect. Motor vehicle theft is an interesting one because there we're seeing, you can see that there the pattern is strongest later in the day. So we're seeing this stronger positive relationship between the presence of people in a location and motor vehicle thefts. Actually, this is starting about 10 a.m. till about 6 p.m. So it's in that later afternoon part. Maybe people going to particular retail locations or that kind of thing, or business locations. There we're seeing a lot more motor vehicle thefts, less so at night. So it's a very different pattern than what we saw for the aggravated assault. And that's the weekend, which is very similar. And then finally, larceny. There we get a very big effect for larceny in the afternoon time period, where it seems like that has the biggest effect between the number of tweets and larcenies. Not as much on weekends, so it's a much stronger effect on weekdays, not as much on weekends. And then finally, we did these extra models where we were asking about if we take into account the number of businesses in a location, which, like I said, is what has been used in the literature as a proxy for where and when people are at locations. We find that tweets still give us more information and above and beyond that proxy. Still remain a robust predictor. The largest reductions for tweets coefficients occurred for robbery and larceny, which might make sense because, again, those businesses can be targets for both robbery and larceny. So in that way, they're capturing that. But for the other types of crimes, not much of a reduction at all. And even for these robberies and larcenies, the presence of people in a location was additional useful information for understanding when and where crime takes place. And again, smallest coefficient reductions for aggravated assault. So in that sense, the tweet information was very useful, and it was very unique information from what the presence of businesses would give us. So some conclusions from this. We think it's a promising approach for measuring the ambient population. There is this ongoing challenge for us of measuring, like I started off saying we want to measure guardians, targets, and offenders. You could try using the tweet of the content, but I don't know if people would say, oh, I'm an offender, I'm looking to place. If they would do that, that would make our job a lot easier. If they don't, and it might take a little effort to try to figure those out. Can we intuit that something from our results? Well, one, it was the case we had a logarithmic relationship between tweets and crime, not a linear one, which we tested as well. So that suggests that, particularly for violent events, they increase at a slowing rate with the ambient population, right? So, as you have more and more people, that would imply that it's the guardian effect starting to slow down the, offender target effect, but that's, somewhat speculative. We saw this really big effect of ambient population late at night, and again, in general, that's coming from a really low baseline, right? There's not that many people wandering around locations between midnight and 4 a.m. So in that case, more people might provide more potential offenders or targets, if you will. And like I said, it was particularly strong from midnight to 4 a.m. where we saw more of the aggravated assaults taking place. For property crime, more ambient population won't typically increase the number of targets, right? It's just, as far as a burglary is concerned, more people there, it's more potential offenders, more guardians, but it's not going to increase targets because targets are only for personal crimes, for violent crimes, not property. And indeed, we detected a weaker relationship between number of tweets and burglary or motor vehicle theft, which is consistent with that idea. That strong relationship between tweets and motor vehicle thefts in the middle of the day makes sense if that's indeed where people are going and parking their car and leaving them, because that's what we do in Southern California, we drive. So maybe more targets there. We're a little puzzled at the tweets and larceny relationship. Why was that so strong than the other two property crimes that didn't quite fit that pattern? It might be that it's more offenders. It would be interesting to try to estimate the age of tweeters and get a better sense if that's the case, but we don't know. That would be something for future work. Limitations, I think we know a lot of these, but we'll just run through these real quick. That of all the many Twitter users, only 23% tweeted in the last 30 days. So again, we're using this as a proxy for the number of people in a location. Our hope is that by combining data over a long time period, we're getting a better estimate. But certainly we have that issue. The population that tweets is not a random sample from the population. It tends to be younger, more education, more urban. One thing is that younger persons are disproportionately likely to be offenders and targets, and that's borne out in the data. So that's not such a terrible thing. The bias towards highly educated persons might, if anything, be a downward bias as far as the locations of where we might find crime. There's also variability in the frequency that different people tweet. And so we try to take into account multiple tweets, but it's still the case that for someone who tweets a lot, we're going to have a real good estimate of where they are. Someone who tweets very infrequently, we have very sparse data, and we're not going to have a very good estimate of that. So that's a challenge for us. It's the case that people are not equally likely to tweet during all different types of events. So at certain types of locations, certain types of places, maybe people are more likely to tweet. That's going to introduce bias into our estimates, upward bias at certain types of locations, certain types of events. It's the case that not many people provide their geographic information. So that's another challenge. And again, if there's systematic difference in who provides their information and who doesn't, that can pose a problem for us in our estimates. And again, like I said before, tweets don't disaggregate population of offenders, targets, and guardians, which is of interest to us at some point. And then we're also curious to know whether these are residents or visitors, and that's some future work we'd like to do to think about trying to get an estimate of where the person lives, and then try to say, and as opposed to where the tweet's taking place, and so to come up with an estimate of that. And I'll pause there. Thanks a lot.
When you identify the tweets as crime-related, do you use a fixed set of words, fixed set of keywords?
We're not identifying them as crime tweets at all. We're taking all tweets. So it's very different in that way. All we're trying to do is know how many people are in a location at a particular time point. So we're not even looking at the content of the tweets at all. Okay. Yeah. That would be something some folks have tried to do that. That gets really challenging to know how do you label
I was
something
wondering if you had tried it.
Yeah. Because I don't know, people are saying, oh, I'm stalking, I'm looking to burglarize this house here. Then we can let the police know. It would be a real policy implication there, previous question.
Like you said, it's rare that someone would post, I'm about to do a crime. But if it's 12:30 in the morning and someone posts, I'm so drunk, I'm going to go in this dark alley, that's a target.
Right.
Would there actually be value to the analysis that you're doing in having this extra information about only one of your three categories?
Anything we could, yeah. I mean, this was like a kind of a proof of concept, because we thought, well, there's so much noise, all those limitations at the end. We just, to us, if we got any signal at all, we were going to be thrilled with it, and we are thrilled with it. Natural next directions to go would be to think about the content of the tweets, and to the extent that we could pull that out, because we know the number of people there. If suddenly I knew in this room that 3 of you were offenders, well, that provides new information to me. So any kinds of more information we can add, we'd like to do that. Any thoughts of how to get tweet content to, you could do it either where you might, I don't know. It'd be useful to know, or even if you could figure out who's not an offender. If you could do that, then you could figure out, well, we know 80% of the people here that typically go here are not offenders. Maybe that would be useful. But that's a direction we could think about going.
I don't know if it's really relevant, but do you consider the possibility of fake news about the Twitter? For example, that the information that is provided is not trustful?
That the Twitter is providing?
Yeah.
I mean, at this point, we're not worried about what information the Twitter is providing, because we're just wanting to know, did you tweet or not? So if you tweeted at a place, that just tells me you're in this location. We're not, at this point, concerned about the information they're providing. It's just not where we're going. Zach.
Of the GPS tagged tweets, what percentage are precise enough to be able to map to the census tract? Because in my experience, a lot of them are only good for the city level. There are certainly ones that are like precise geo points, but just so happens that when I've looked at them, that I can't use all my GPS tweets to be as precise as you want. So I'm just curious if you could speak more about that.
Yeah. So So you're getting ones that are lat longs, but when you plot the lat long, it's to the center of the city. Is that what you're finding, or what do you?
Well, so I get them from the streaming API, and they provide bounding boxes that are for like a city, or maybe they'll call it like a neighborhood.
Yeah.
But that's still bigger than a census tract.
Yeah, that we've not used, because we've only gone with the ones that provide the precise lat long, because there are this other chunk of ones that provide these other areas, and they quickly, for our purposes, they get way too big. They're not as useful for us. I mean, it would be interesting, and we've thought about that, to use it, because right now we're getting only ones that are in a particular place, and we can count that well, and then these other ones that we can locate to much bigger areas, we just ignore. Now that's not great, right, to ignore them, but then you have this question of how do you do some sort of spatial smoothing, or how do you put them somewhere within that bounding box. That, at this point, the decision was just to get rid of them. For future work would be to think about how, other than, you have to make some assumption, obviously. You put them you just do a uniform distribution, and that's where they're located, or do you do something else? I can imagine trying to use the content of the tweets to make it a little better, because it's an imputation problem, right? In this case, it's a spatial imputation problem. But could you build somewhat of a better model? But we haven't approached that at all. Have you given that any thought, or trying to do that, or?
I just keep things at the city level.
Yeah. There's a good thought. See, we get down to the small units, so that's. Yeah. It's a fun challenge that you pose. But
I have one question. John, you showed the temporal relationship. Have you done any research about the spatial relationship? Like, if you know that Irvine is a very safe city.
That's right.
Whether that information is consistent with what you see from tweets. Right? Not the temporal, but spatial.
Oh, I see what you mean. Yeah, because in this case, we're just getting a single coefficient that's estimated over the whole region. And so you could do, we do this at times where we get, geographically weighted regression is one way to think about it, but you're getting an estimate over space for this tweets crime relationship. That's an issue we gave as a first cut. We didn't even think about that. That's a great idea, though, to ask, whether it differs. Because Irvine and other places like that, we have much less crime. Does that mean? Well, I guess that would be one thought. Is you'd expect the relationship, because there's. Well, I don't know. I'm not even speculate why, but that maybe it would be a different relationship. That's a great idea. We haven't done that yet, though. Yeah.
John again. So